page 61, number 2, trying to figure out which one of these does not belong. Well, what I'm going to have to do is I'm going to have to multiply this out. I can already see that these first two are different. See how they have the coefficient of x is squared is the same, but the b values are not the same. So I know that these two are different. So now I'm just going to check this one. The way that I do that is I'm just going to multiply it out and keep multiplying it out. Okay, so does that match one of those two? Yeah, matches this one, doesn't it? So it must be that this is the one that does not belong. So if you wanted to check this one, you could. Watch how I multiply this one out. To multiply it out, it's going to be 3, and when I square this out, it's going to be x squared plus 2x plus 1, and then minus 27, distribute the 3. And see how this is going to end up being the same thing. But once I figured this one out, I could have stopped. Because if this is the same as that one, that's got to be the one that does not belong. Okay? So it should have been that. All right, what else on the evens? Okay, what about on the odds? Anything you didn't understand? Yes, okay. Okay, let's take a look at number 69. Okay, so this one says, an online music store sells about 4,000 songs each day when it charges $1 per song. For each 5-cent increase in price, about 80 fewer songs per day are sold. Use the verbal model and quadratic function to determine how much the store should charge per song to maximize daily revenue. Well, this right here is our revenue function. They're making $1 plus 5 cents every time they raise it by a nickel. That's going to be the price. Their sales, though, they drop. They sell 80 fewer every time they raise it up by a nickel. So X then is representing how many times we're going to raise it up by a nickel. So what am I going to try to find for this, though? How am I going to find the maximum? That's the same thing as what, Zane?
The top of the graph. Yeah, well, the maximum.
Yep, the maximum, right.
Well, you said the maximum, so I was like.
I know, yeah, that was a bad question, so we'll give you a break. Okay, so we're going to type this into our calculator. We have 1 plus 0.05x times 4,000 minus 80x. Now, most of you would probably do a Zoom 6. That's what we've kind of been taught to do. So here's the way this revenue function looks. We're not seeing much of anything. We've got to know how to change the window. We've got to be persistent with this. I know that the least number of times I can raise it up by a nickel would be 0. The most, I don't know, 50? Could be more than that. The Y's, though, if I don't do anything, it's going to, if I plug in 0 for X, what am I going to get? 4,000. So I know my Y max has to be larger than 4,000. I'm going to make it like 6,000, see what happens. We'll see if I see the whole function. Not bad. Usually you have to go back and change it even more. All right, so now I just want to find the maximum. So I do second, trace, calculate. Number 4 is the maximum. I have to go to the left side of it. Get that. Go to the right side of it. Hit enter. And then it's going to say, is your guess, is it in between those two? I say enter, say yes. And there it's telling me x equals 15. So if I do this 15 times, there's going to be my revenue, 4,900. If I did it 10 times, here would be my revenue, 4,800. So see how that maximized it. So again, that was 15. So on number 69, we're going to say 15 raises by 5 cents. Okay, now let's see what the question asks us to answer. Determine how much the store should charge per song. So they're going to charge $1 plus 5 cents times 15. What's that, 75? So it's going to be $1.75 per song. Okay. What else? Any others on anything? Okay. So let's go ahead.